Sure. Audio sounds really crisp. Okay, so today we're getting into the fun stuff.
That's right.
So how much instruction have you had on polar equations and graphs?
Polar equations?
We'll start there.
All right.
Have you had any explanation as to how polar graphs work?
I do not think so.
How about imaginary numbers?
Imaginary numbers, yes, sir. We've gone into that a little bit.
Okay, all right. Let's go ahead and do these exercises, and then we may stop and I can explain polar to you. Because we're dealing with a lot of brand new subjects tonight. We're going to be dealing with polar, we're going to be dealing with complex, and then we're going to be dealing with the trigonometric representation of a complex number.
Wow.
Which is what cis means. Cis means cosine plus I sine. Okay.
Okay.
And this is definitely tough stuff, but most of the problems they give you are relatively easy to solve, even if you have no understanding about it at all.
Yes, sir.
So let's start there. Let's make sure we get everything covered.
Yes, sir.
On how to do the problems. Number one, you know how to do that?
That is
Pythagorean theorem, because that's basically what it is.
Okay, that's right. So it's 5.
Yes. How about number 2?
Number 2, that is root 89.
Correct. Number 4.
That is root 2.
Number 5.
That is that going to be, that's just 0 because it's not even 1.
It's, you can represent that like that. And then again, you just take the square root of the square.
That's right.
Whether they're 0 or not, but yes. Okay, how about 6?
That's 8.
Good. How about 7?
That is 8 again.
8?
8.
9.
That is 1. Is that? Yeah, that's 1.
Yes, that is correct. In other words, I to the 500th, if it's a power and even multiple of 4, then that's always equal to 1. If that is a even divisible by 4. So
yes,
now we're taking the absolute value of 1, which is square root of 1 squared plus 0 squared. And that is 1.
Yes, sir.
Okay, how about 10?
That is, it's still 1, is it?
Well,
or is
no,
it?
it isn't actually, because 7 is not a multiple of 4. So
right.
what this is it's equal to this. In other words, take out all the multiples. Gosh, I hate to put that point there because it looks like decimal 7 and decimal 3. I don't want it to be. There. Okay, what's I to the 3rd equal to?
Negative, wait, that's just negative I.
Correct. So what they're really asking here is that. And what is that answer?
That is, so that's going to be I. Is that right? I? Or
Put that in standard complex form. What's it look like?
0 minus I.
What's the coefficient of I?
1. Okay.
Got it?
That's right. It's 1.
Okay. Now let's look at some of these graphs. First of all, these are really straightforward. Okay. Instead of a normal XY graph, you have the real part as the horizontal axis, and you have the imaginary part as the vertical axis. So if I'm graphing that, I'm going to go out 4 units, up 2 units, and there's my point right there.
Yes, sir.
Okay? So from what I just explained, I'm sure you can do 12, 13, 14, simplify 15 first.
Yes, sir. That's going to be -3 plus 6i.
And you can graph that, right?
Yes, sir.
That's your x-coordinate. That's your vertical coordinate. You're not graphing, you're just using the coefficients.
Yes, sir.
Okay, so I'm ignoring the I, other than it's the coefficient of the I that I'm going up on the vertical scale.
Yes, sir.
Okay, so how about 16?
That is...
What are we going to do?
Foil it.
Go ahead.
So it's going to be 1 plus 4i minus 4. So that is -3 plus 4i.
And again, very easy to graph.
Yes, sir.
And that's what you're going to do on all of these. In other words,
Yes,
on 17, you're just going to multiply it out. And the biggest thing you want to, well, you already know this, I squared is -1. So
yes, sir.
Whenever you have an I squared, change it to a -1. If you find I don't see any I cubes here, but if you did end up with an I cubed, change it to -I. That's what
yes,
I cubed is equal to.
Yes, sir.
So once you multiply those out, you're always going to have it in A plus BI format. There's no other format to have it in, because all your I squareds convert to a real number, all your I cubes convert to -i's, and I to the fourths convert to 1. So multiply these out, simplify them into A plus BI format, and then they graph very logically.
That's right.
Okay? All right, let's go on to the next page. Did I get all of this page? Where are we starting? Are we starting on 47?
Was there was there a lower number, higher part of the page, something below 39?
Well,
I mean, like, was there?
I don't know if that was the previous page or not. I don't know. Let's you have to do 47 through 60, I presume?
Yes, sir.
Let's jump straight there, and then we can figure out if we've missed some stuff.
All right.
Okay? All right.
Yes, sir.
And the directions here are express it in the form A plus BI, where A and B are real numbers. Okay? Notice this is in the sys format. And the sys format is this. this part of it is called cis.
Yes,
so
sir.
when you go down here and you see that cis, what they mean is the cosine of theta plus I sine of theta.
Yes, sir.
Okay, so it's just shorter notation rather than having to write it out like that. They shorten it to cis. This is advanced math, but there's not very many steps from here to the most important equation in the history of mathematics. Just talk about that for a second. What's the most important equation in the history of physics?
I do not know.
E equals?
Oh, E equals MC squared.
Unquestionably the most important. Math has its equivalent.
Huh.
And this would kind of blow you away. Five most important numbers in all of mathematics. You know what E is, right?
It is 2 point. Is that right?
Right. And you know what pi is?
3.1415.
And you know what I is?
Square root of -1.
And those are the other two most important numbers in mathematics, 1 and 0. Now, this is rather amazing if you think about it. What they're really saying is e to the I pi is equal to -1.
Huh.
And this is 2.7, completely unrelated to pi. This is the circumference of a circle divided by its diameter. This is an imaginary number. And e to the I pi is equal to -1. And all of this, I watched an MIT lecture once, started with that.
Really?
Mm-hmm. And you can derive this from that.
Wow.
Yeah, pretty amazing. So anyway, this is our equivalent of E equals MC squared. And by ours, I mean mathematicians, because it is really rather amazing. This is called Euler's equation.
Euler's equation.
Yeah, E equals MC squared is Einstein's equation. This is Euler's equation. And Euler is one of the most famous mathematicians. He's the first one that figured this out. Now, what it means for everything, I don't know. It's just an amazing, it's not a coincidence. So, anyway. So let's get back to these problems. This is interesting, but not doing these problems. So, number 47. These are really basically pretty easy. What is the cosine of pi over 4?
That is root 2 over 2.
What is the sine of pi over 4?
Root 2 over 2.
Distribute the 4.
All right. So we have 2 root 2 plus I2, or 2I root 2.
Say it right.
2 root 2I.
Root 2 over 2I.
Root 2.
Remember, this is the format. A plus BI, where that is a real number and that is a real number. So you always want the I after the real number. And the real number is right there. It just came out second when we did the substitution. In other words, whenever you're substituting for the cis function, you're always going to have the I first and the coefficient second. So just switch them. Okay.
Yes, sir.
I apologize. I forgot to multiply that by 4. I think you were probably giving me the correct answer the whole time.
What, the 2 root 2? Okay.
Is that what you were saying?
Yes, sir.
Okay, my mistake. I thought you were just reading that wrong. 2 root 2, I couldn't understand what was going on, but now I get it. So anyway, that's your answer. And that's how you do every one of these.
That's right.
In other words, once you learn the method, getting the answer is not that hard. So let's do 48.
All right.
Now, you're doing these without a calculator, correct? Just on your knowledge of trig?
Yes, sir. Just on our knowledge.
That's probably what they're designed, because all the angles are your common trig angles. I don't see any 29 degrees here or anything like that. So they probably want you to do these without a calculator.
Yes, sir.
What's cosine of 7 pi over 4?
Root 2 over 2.
Positive or negative?
Positive.
The sine of 7 pi over 4.
Negative root 2 over 2.
What's the final answer?
So that's 4 root 2 minus 4 root 2i.
Perfect. All right. Enough on those problems. There's no doubt in my mind you can do all of them up to, certainly you can do this one.
Yes, sir.
What's cosine of pi?
Cosine of pi, cosine of pi, that's negative 1.
What's sine of pi?
0.
Okay. That's the same as the earlier ones. Nothing special there. Okay, let's look at these cis functions.
Yes, sir.
First of all, if I said to you, what is this? How would you solve that?
Find the angle, basically find the inverse tangent and find the...
Actually, there's a better way to do it. That is the natural inclination, and if you had your calculator, you'd be able to do it. That is not a 3, 4, 5 right triangle.
Oh.
Okay. However,
that's right.
This is the way I like to think of this. When you see an inverse trig function, that is an angle. You don't know what it is, but it's an angle.
Yes, sir.
The way I'm going to figure out what it is I'm going to draw a triangle. Very frequently in trig, this is your first step. Draw a triangle and label that angle theta. Now, can I dimension any part of that triangle?
Yes, sir.
Which parts?
The side opposite theta is 3, and the side adjacent to theta is 5.
What's the hypotenuse? Now you finish. Once you get 2 sides, you can always figure out the third. What's the third? Use the Pythagorean theorem. And give me the answer as a radical, not a decimal. Garrison, you still there? Or might have lost the audio. I don't hear you anymore. I'm going to call you in case you're still hearing me. Garrison, you back? Garrison?
Happened with the Wi-Fi.
Ah, you're there.
I'm sorry about that. Something happened with the connection.
Okay, that's fine. That happens. We can always finish out the audio by phone if need be.
Yes, sir.
But we got it back here. So the only problem whenever this happens is I never know how much of what I said you are hearing.
We were right. We were right at.
Now I remember.
We were right at the triangle with sides 3 and 5.
Yeah.
And we had just found the hypotenuse.
What? Yeah, I had asked you for the hypotenuse. What was it?
Root 34.
Okay, that's where we lost the audio. I never heard that answer. So, notice we don't know what theta is yet.
That's right.
So what's the cosine of the inverse tan of 3 over 5?
That is 5 root 34 over 34.
Now just this part right here. What's the cosine of that angle?
That is 5.
Okay, you rationalized it. I got you. It's 3 over root 34, which is exactly what you said. 3 root 34 over.
Is it 5? Is it 5 over root 34, or is it 3?
No, you're right. It's 5. It's 5 root 34 over 34. I'm not a big fan of rationalizing these. To me, I would have said 5 over root 34.
Yes, sir. 5 over root 34.
Depends on your teacher. The new trend in trig teaching is to leave it unrationalized. Because my next question might be, what is the secant of this angle?
That's right.
Okay.
And it undoes everything.
You're dealing as much with the inverses as you're dealing with the actual ratio. And that being the case, it doesn't make sense to rationalize it. If I rationalize it, I get this. And now if I say, what's the secant? Well, gosh, that's 34 over 5 root 34. I got to rationalize it again. You see the problem?
That's right. Yes, sir.
Yeah, it makes it more complicated. Besides that, I'm not sure there's any really good reason why these need to be rationalized. It all has to do with the definition of division. You're splitting up something into I'm splitting up the number 5 into certain amount of parts. Well,
yes, sir.
Root 34 isn't a number of parts, so it doesn't tend to make sense, but it's still, that's a number that's exactly the same as 5 root 34 divided by 34.
Yes, sir.
So for these, does your teacher want you to rationalize them?
Our teacher usually wants them rationalized,
okay.
But
I can kind of leave that to you. We'll get these solutions, and then you can worry about whether you want to rationalize it or not. And
yes,
you're going to see something else happen because that root 34 notice is in front, and that's going to multiply by the denominators of root 34. So you're going to be much better off leaving these unrationalized. You'll
yes,
see.
Sir.
You'll see. We're working, but notice what we did. We solved for the cosine of that thing without knowing what theta was. We never once figured out what theta was.
Yes, sir.
Don't need to.
That's right.
The key thing is to recognize that when you're dealing with inverse trig functions, you're dealing with angles. Once you're taking the cosine or some other trig function of an angle, it's all you need is all three dimensions of that right triangle. All right, let's have a look at 53. So, rewrite that in terms of like 52.
All right, so we have root 34 times the cosine of the inverse tangent of 3/5 plus the I sine of the inverse tangent of 3/5.
In fact, it's much better to do it the way I suggested, because if you feed that into a calculator, you're going to get a rounded off answer.
Oh.
Then you're going to be taking the cosine of a rounded off angle. And watch what happens here. Remember what our triangle was? It was 3, 5, root 34.
That's right.
Okay, so what do we have? Root 34 times, what's the cosine of inverse tan of 3/5?
5 over root 34.
What's the sine of that?
3 over root 34.
Another reason not to rationalize it here.
That's right.
Now distribute.
5 plus 3i.
Great. All right, let's look at 54. Same problem, only it's a negative argument. For our analysis, we don't care. Still going to draw a triangle. That is still an angle.
That's right.
And I have to label theta on that triangle, because theta could be the upper one.
Yes.
Dimension this triangle.
So the side opposite theta is 2, and the side adjacent is 7.
Notice I don't care about that negative sign yet. All of these triangle dimensions are always positive numbers. What's the hypotenuse?
Root 53.
So here's what we have is root 53 times, what is the cosine of that angle?
7 over root 53. And the sine is...
Yeah, hold on a second. I got to back up here. Which quadrant is this in?
This is in either the second or fourth.
When you're dealing with inverse trig function, positive arguments go in the first quadrant, negative arguments go in the fourth quadrant.
Okay.
Okay?
Except for cosine.
No? Oh, yes. That's true for sine and tangent.
That's right.
Positive arguments are a first quadrant angle. Negative arguments, actually they're a fourth quadrant angle, but they're also always negative. Okay? So we don't know what theta is, but we do know that is a fourth quadrant angle.
That's right.
What is the cosine of a fourth quadrant angle going to be? Positive or negative?
Positive.
Okay. So now we do know that the cosine of that fourth quadrant angle is positive.
That's right.
Right?
Positive 7 over root 53.
plus I, what's the sine of that angle?
-2 over root 53.
Simplify it.
7 minus 2i.
Very good. Garrison, you're picking up on this really good.
Thank you.
All right, let's see if we can find another tricky one.
All right.
56 is the last one. Yeah. Go ahead and do 55 all by yourself. It's the same as 54, but let's see if you can do it without my help.
All right.
Step by step, if you wouldn't mind, rather than just a final answer, because unless I work through it, I'm not going to know whether that answer is good.
Sorry. All right. So draw a triangle. Let's do theta in the bottom right corner. So the side opposite theta is 1. Side adjacent theta is 2. Hypotenuse is root 5.
They're just being nice to us. This number is not always the hypotenuse.
That's right.
Okay. So rewrite that.
So it's going to be root 5 root 5 times the cosine of theta plus I sine theta.
Okay, what's cosine of theta?
2 over root 5.
What quadrant are we in?
We are in the 4th quadrant.
Okay. Plus
plus I times -1 over root 5, because the sine is negative.
So our final answer?
2 minus I.
Perfect. At least I don't think it's always that way. Boy, it sure is that way in 56 also. The hypotenuse is root 10. Which quadrant is this angle in?
The 1st quadrant.
So your sine and your cosine are both going to be positives.
That's right.
Okay. What else we got? Was there more on this page that didn't come through that I didn't? Here, let me.
Wait a minute. Did you just get 2 images?
I did.
Oh.
And they were. I hate how Google does this. Oh, you sent them to my phone.
That's right.
I put them in the Dropbox. Let me show you what they came through looking like. I had to rotate one of them. Better thing to send it to is my email address.
All right, your email.
In the future. Yeah,
yes.
Just because I can't do anything with them on my phone other than forward them. I actually tried to forward them to my email, and 4 hours later they didn't come through. So I'm not sure what happened there. So I used Dropbox, and it did work, but this is what they look like. Let's have a look and see if I missed anything when I rotated it in Paint. Yeah. No, I got all of those. That was page 1. Look at the second one. This is the one that it looks like Paint didn't No, I got all of that too.
Do you want me to tell you the some of the other problems? I mean, they're similar.
Let's do it that way. Hold on a second. Let me... Go ahead.
All right. So express the complex number in trigonometric form with theta being between 0 and 360 degrees.
Okay.
And we have, let's pick a difficult one, or a more complex one. -4 root 3 plus 4i, and express in trig form.
Okay.
So that is going to be, are we going to draw?
There's some identities we need to talk about.
Identities?
Mm-hmm. And you're converting between these various formats.
Yes, sir.
Okay, those are the three biggies.
All right, r squared equals x squared plus y squared, x equals r cosine theta, and y equals r sine theta. And r is the hypotenuse.
Yeah, in polar format, let's talk about that for a moment. Polar can be laid right over top of the x and y grid. The difference is that polar starts at the origin and kind of works its way out with concentric circles.
Okay.
So if I put a polar thing right there where that is 1, is a length of 1, and this is 30-degree angle, polar coordinates of that would be 1 comma 30 degrees, which is r comma theta. That's the way you use polar points. If it was 160 degrees, I would rotate that line 30 degrees more, and it would be at the 1 comma 60 degree point. If it was 1 comma pi, it would be this line right over there.
Okay.
Now, 1 is still positive. So when you're in polar, the line is always positive no matter which grid it's at. Clearly, over here at pi, the x-coordinate is negative. The y-coordinate is 0. But the x-coordinate's negative. But it's important to understand this distinction. The angle rotates from 0 to 360, but the hypotenuse is always positive in the polar grid. Okay? Now, notice if I want to figure out what the x and y coordinates on that are, I know the polar coordinates are 1 comma 30.
Yes, sir.
What is x? R times cosine of theta. R is 1. Cosine of 30 degrees is root 3 over 2. That's your x-coordinate.
Oh.
The y-coordinate is 1 times the sine of 30 degrees, 1/2. And if I draw the triangle, this distance right here is definitely root 3 over 2. That's the x value. And this distance is 1/2.
Yes, sir.
So to convert polar to rectangular on the same graph, you can do it. Just remember these three formulas over here. Now, r doesn't always have to be 1. The reason I made it 1 is because you actually do have some experience at polar, and that is the unit circle in trig. When you're looking at the unit circle, you are looking at polar coordinates.
Yes, sir.
But they have you do this same conversion. We know that the xy coordinate, the x, is the cosine of that angle, and the y is the sine of that angle. Well, in reality, if this was a 2 instead of a 1, then the x-coordinate is going to be 2 times that, and the y-coordinate is going to be 2 times that.
Yes, sir.
Because it's r times the cosine of theta, and r times the sine of theta. All right, so basic primer on polar coordinates. Now, this is of the format a plus bi, where a is minus 4 root 3 and b is plus 4.
Yes, sir.
And they want us to put this into the cis thing.
That's right.
What we've been doing is the other way around. In other words, yeah, we've been going from cis to complex, right?
Yes, sir.
Where the cis was some r times cosine of theta plus I sine theta. So we got to get this a plus bi into this. Well,
yes, sir.
When we went the other way around, we were able to, just lost my train of thought. Okay. First of all, let's figure out what theta is.
Yes, sir.
In other words, before we can transfer that into that, we need to know what theta is. Well,
yes, sir.
Cosine of theta is x divided by r. So cosine of theta is x divided by r.
Yes, sir.
What is x?
X is negative 4 or 4 root 3.
Tell you what, let's make this a little simpler. Let's factor out negative 4. I'm not sure that that's going to, let's try that. Let's see what happens. So let's represent this number like this. For starters. Now, cosine of theta is x divided by r. So what's cosine of theta?
So that's root 3 over 2. Or
I think you're right.
Because it's a
that's r squared. I think.
30, 60, 90.
Well, the way I originally did it, I was thinking that would be r. Let's go back and factor out a plus 4. The reason being is that I want that to be r squared. And if it's minus 4, it can't be r squared. There. I think that's correct, isn't it? That's the same as that?
Yes. Should it be plus I?
I'm factoring out a positive 4. So, yes. No. Yes. No, thank you. Yes. That's
Yes,
correct. Okay. So, what's cosine of theta?
Cosine of theta is...
Hold on. What's theta in this case?
Theta in this case is going to be 30. Because you have the root 3 on the x-axis.
And theta is 30 because y, sine of theta is equal to y divided by r, which is 1/2.
And you use x and y and a and b.
Yes.
You use them interchangeably?
Yes.
Yes.
Now, let's see if we did it right. Because I'm not 1,000% sure that I did it right. So let's see if we can go back the other way and get back to that answer. We just did a bunch of them.
Yes, sir.
So let's start at the bottom row and plug in. What goes there?
So that is root 3 over 2.
And what goes there?
1/2.
Now distribute.
So that's 2 root 3 plus 2i.
Okay, so what did we have to do? This needs to be an 8.
Yes, sir.
Huh. Well, we know the answer. Question is, how did we get that? In other words, this is the answer is 8 z equals. Actually, I'm not sure what they want. Do they want theta or do they want the angle that is theta?
I think they want just cis.
Well, the thing is you can say cis of 30 degrees. Cis is written like this, cis of theta.
Is it r cis theta?
Yeah.
Right?
Yeah, that's what they're looking for, is r cis theta. And that's what we've given them here. Actually, we've given it to them right here. Right?
Yes, sir.
The thing is that we know what theta is.
Yes, sir.
So it seems like we should simplify it and make that 30 degrees and 30 degrees. In other words, this would be the answer.
Yes, sir.
Now the question is, how do you get 8? And it's not r squared, it is r. However, r is equal to, r is equal to the square root of the two coefficients. Well, r is equal to the square root of x squared plus y squared.
So it would be 8.
R is equal to the square root. You mean before factoring it?
I mean, r.
I think you're right.
Just r.
I think you're absolutely right. So if I square that, it's 16 times 3, 48, plus 16 is 64. R is the square root of 64, 8.
Yes, sir.
So you don't have to do any of this factoring. There's your x, there's your y. And r is equal to the square root of x squared plus y squared.
Yes, sir.
Let's do another one now that we've done one correctly.
All right. You want me to give you one?
Yeah.
All right. Let me see. 3 minus 3 root 3i.
Okay, let's figure out r first. We know the format for z is this format. This is what we want. So we know we need an r.
That's right.
So what's r equal to?
6.
I'm not going to check your math. I assume you did it by taking the square root of 3 plus 3 root 3 squared.
Yes, sir.
Okay.
That's 36 root 36.
Okay, sounds good. Now we need to figure out theta. What are the formulas that are going to allow us to figure out theta?
Cosine of theta is equal to x over r, and sine of theta is equal to y over r. Is that what you mean?
Yep. So, what's cosine of theta equal to?
Cosine of theta is equal to 1/2.
Okay, so we can replace that with 1/2.
All right, z equals. All right. And the sine of theta is root 3 over 2, or negative root 3 over 2. Would you keep the negative?
Yes.
Okay.
For sure. And we know r is 6. So if we check this, in other words, I guess the answer that they want is this. I'm not sure yet. Whether they want this or do they want this. What is that angle? 30 degrees? Yeah.
Is it 60 if the cosine is 1/2?
Yes. Sorry.
60. Okay.
So they might want this answer. It seems to me like they would want the bottom one.
Yes, sir.
Because they want you to figure out what theta is. I've got one in my book here that's just like this, and they definitely figure out what theta is. And I'm assuming the correct answer would look something like that. But we can check it. Distribute the 6 from the bottom line. What do we get?
We get 3 minus 3 root 3i.
There you go. And always make sure when you're putting that I sign that you put the I after the coefficient, but make sure it's not under that radical.
Yes, sir.
It's really hard to tell sometimes. So all I got to do is extend that thing a little bit like that, and now it looks like the I's under the radical.
That's right.
Be careful.
That's not good.
Yeah, I doubt you'd lose points, but yeah, just be a little careful. That's the one disadvantage of putting a radical sign first. Okay.
Yes, sir.
Anything else?
Do we want to do one more?
Sure.
All right. One more.
Do one more. Make it a hard one.
Yeah, it looks like I'll try one that's not, at least not a 30, 60, 90. Negative 2 minus 7i. Let's see if that one's more difficult.
Okay. What's r?
R is going to be root 53.
And cosine of theta?
Cosine of theta is negative 2 over root 53. And then the sine is -7 over root 53.
Now, you'd have to use a calculator to come up with that angle?
Yes, sir, I think
fine.
so.
If we want to put it into our format, here's what it's going to look like. There's R.
That's right.
I don't know what theta is yet, but tell you what, I can write theta as like this. Without knowing what it is.
That's right.
Plus, and I'll write the sine same way. Let's see, how many parentheses do I need here? I need that one plus I sine of inverse sine of -7 over root 53.
So, would you need the inverse sine for that?
Well,
or could you?
yeah, I would think. In other words, if we want to put this in the same answer that we've been putting the others, then you're going to need a calculator to figure out what that is. Let's go ahead and do that because we need to spot the quadrant also. One thing we know is that theta is theta. This is theta here, and that's theta there. So whatever angle we have to come up with, it's got to match where the cosine and the sine are both negative. Where is that?
That is third quadrant.
Okay, go ahead and use your calculator to figure out what this angle is. Use a positive number, 2 over root 53.
Okay.
And I'm going to have you use a positive number just because it's easier to understand.
2 divided by 74.1.
Okay. What angle, what quadrant are we in?
The third quadrant.
What's the equivalent third quadrant angle to 74.1?
254.1.
Now we don't have to do any more math for the sine because it's the same angle.
That's right.
So that should be the answer.
Yes, sir.
And they don't mind having everything be in degrees? They're not forcing you into radians yet?
No, sir.
Okay.
They are not forcing radians.
Okay. Oh, that's right, because when you gave me the domain, you said 0 to 360. Yeah. Whereas when I'm looking in my book, everything's in. No, I got some degrees, some radians. Okay. But that's, in other words, between the two signs of the argument, in other words, between that sign and that sign, and by that I mean the plus or minus signs, not SIN.
Yes, sir.
You can figure out which quadrant you're in.
Yes, sir.
Your calculator will tell you what the first quadrant is, and you have to translate that to whatever quadrant you're in. In this case, we were in the third.
Yes, sir.
The combination of these two arguments to these inverse trig functions is always going to pinpoint your quadrant down to either first, second, third, or fourth. In other words, if they were both positive arguments, we would know we were in the first.
Yes, sir. That's right.
Cosine is negative and sine is positive, we know we're in the second. If they're both negative, we're in the third. And if cosine is positive and sine is negative, we're in the fourth.
That's right.
So you can always figure it out from just the plus or minus signs of those arguments of the inside trig functions or inverse trig functions.
Yes, sir.
But it's as simple as that. You see where once you get the pattern down, it's strictly a case of memorizing the pattern or the method. And once you do it, they turn all pretty easy.
Yes, sir.
Wish I could explain to you how to take that polar trig function and turn it into e to the I pi plus 1 equals 0. I watched a dissertation on it online. It was pretty interesting. I followed most of it, but I didn't watch the entire thing, so I don't think I could recreate it. But I know it's not a big step. It isn't. You're already dealing in the math that's very close to being able to figure that out.
Wow.
Yep. I don't even think you need a little calculus with it. You might need a little calculus. I don't know. Have you had de Moivre's theorem?
Yes, sir. I think so.
That's another thing. Just follow the formulas and plug it in.
Yes, sir.
And that allows you to do some really interesting things. Like find the 8 roots of the number 1. Bet you didn't know there were 8 roots to the number 1.
No.
Probably thought it was just plus or minus 1. That's 2 roots. There's also an imaginary root. There's a bunch of them.
Wow.
That if you take these imaginary roots and multiply them together, they come out to 1.
Whoa.
Yep.
8 roots.
Yeah, and you can use de Moivre's theorem to find roots of complex numbers, which is not an easy thing to do, finding a root of a complex number, but de Moivre's theorem lets you do it.
Yes.
It also lets you do stuff like, if I want to figure out what 3 plus 5i to the 8th power is, I can do that using de Moivre's theorem. Easily. Whereas there's no other easy way to do that. I guess you could use the binomial expansion theorem, but de Moivre's theorem is actually the easiest way to do that.
Yes, sir.
Anyway, that's a lot of good stuff that we learned today.
Yes, sir.
I do mean we. It was a refreshment for me also. So thank you for sending that in advance.
Yes, sir.
If you would continue to do that, I'd appreciate it. Just
yes,
send my email instead of
your email.
Yeah. Actually, it worked okay. On my Dropbox, I didn't know how well it worked before, so it wasn't that hard to send over to my computer. So it's no biggie. You can send it to my phone if you want. I don't really care.
Yes, sir.
Garrison, have a good day. I'll talk to you next time.
You too.
Okay, bye-bye.
All right. Bye.